Welcome. This is the SF Big Analytics Meetup, and we are partnering with AI Camp to bring you a great talk today, getting the most of your data with open metadata. And I'll just introduce our speaker very briefly. We have Suresh Srinivas here. Suresh was the chief architect of Uber's data platform. So we're super excited that he's here to talk with us today. Responsible for all data initiatives at Uber, including data book, data quality, data lineage initiatives, some hot topics. Suresh was part of the original team that built Hadoop at Yahoo and subsequently co-founded Hortonworks, which developed and supported open source software designed to manage big data and associated processing. Suresh is leading the Open Metadata project to build metadata APIs and specifications and a single place to discover, collaborate, and get your data right. So Suresh, thank you so much for being here, and I'll give you the floor.
So with that introduction, Anya, I don't think I need to go through any of the PPT. It was pretty comprehensive. Thank you, SF Big Analytics, for arranging this talk, and thanks everybody for taking some time off from your busy day to attend this. I'm very happy to represent Open Metadata project, the community of Open Metadata project. So Open Metadata is an open source project, one of the fastest growing open source projects in this space in data. And our goal is to, as Anya said, build open standard for metadata. I'll explain why that is required and how we are doing it. And then also an application on top of metadata, which is a single place to discover, collaborate, and get your data right. I will explain all of these things as we go through the slides. So now who are, Anya introduced me, and I have, some experience in the data world, and I've seen how things have transformed, especially, the wave of big data, and where we are right now with all of those transformations that have happened in 10, 15 years. But it's not just me, right? So we are a bunch of open source developers passionately building this project with a lot of open source experience. We are also a team, that is globally distributed, that is contributing to, the core team that is contributing to open metadata. We have lots of experience in building scalable things, and most importantly, we have lots of experience making a lot of mistakes that, we have learned from, and hopefully with open metadata, we are going to be making newer, newer mistakes, and not repeat the older ones. So, and I'll also explain how they are, what they are, and this is sort of like third generation of metadata system that I'm building. So I'll explain how it is different. So why open metadata? Right, what problems it is solving, what applications it enables. Those are the things that I would go over in this talk. And then I'll also give you a demo and some pointers to, take your own, check our project out through our sandbox. So I'll, give you the starting point of that. So this is based on my experience, and a lot of times, right, in the busy, reactive way of dealing with data, we forget, where we came from, what happened, and where we have arrived, and what are the issues. Just recapping, right? In last 10, 15 years, digital transformation has happened in every industry, right? And because of this, there is explosion of data. The second thing is billions of dollars have gone into big data and cloud, where there are platforms and services on-prem, in the cloud. So now you have very powerful scalable storage and compute of various kinds, right? Real-time, batch, and all of that. Now, one thing to note here is many of these platforms over the last 10 years that are developed, winners and losers are emerging, and consolidation is happening. And this space of storage and compute is consolidating, right, and becoming mature. And hence now we don't need to do benchmarking wars and this and that. Now is the time to build on top of these platforms and have successful outcomes with data. And then the last thing that you can see is, if you look at 10, 15 years ago, most companies would have maybe 3 to 5 people. They have very limited data. They understand all the data, and they were just generating some data reports, dashboards, and things like that. Very limited number of them for very few people. that is no longer the case, right? So everybody wants to be data driven, right? So there are a lot of people now using dashboards, metrics, even people who are not skilled at data, not developer like. Their life is dependent on data, right? Through data, driving their decisions through data, and hence you see all of this words coming out, right? Data democratization, so that everybody should use. A single team cannot handle all this data, and hence there are distributed teams, and there are new personas that have emerged around data. So now data is being done by essentially distributed teams, different personas having different kinds of skills. Now, in such an environment, right, so organizations have made huge investments in platforms. They've also thrown a lot of data developers, right, to get better data outcomes, decision making through data, machine learning, and all of that. And they've also purchased a lot of tools, right? Data has a tool explosion right now, and people have bought a lot of tools. I'll talk more about this. But still, right, if you look at a lot of companies, even companies that have been doing data for a long time, basic things are broken, right? So to give you an example, from Uber, we would have core metrics like, hey, how many trips happened last month? Depending on the data scientist you ask, you would get different data scientists will give different answers. We have had cases where we have generated reports and there are discrepancies, missing data and things like that, which was flagged by somebody who received the report, right? Not flagged, we did not detect them internally. And so there is general, creating outcome with the data, works okay, but that outcome is not reliable and silent failures happen, right? And all of this is, causing lack of trust in data. It is also, reliability has become a big problem, right? So without going into a lot of these details, reactively people are throwing people and tools at the problems that they are finding. And if you step back and look at it, right, one thing is very clear: data is not organized for people. And this is where some of this data mesh and data fabric, some of this importance of data catalog, is becoming very important, right? So this is just organizing. How do we organize data, right? But what is missing today is, based on my experience of solving some of the problems at Uber, people are not organized for data, right? So we've just done, in an ad hoc reactive manner, we have organized around around data, and there's lack of collaboration. There is lack of connection between people, especially given it is distributed team. So data mesh is not sufficient, right? People mesh is also important if you want good outcome with data, right? So now we believe if data is an asset, metadata is a key to unlock the value from that asset, right? And today metadata is not done right? So a lot of metadata is just lost, right, in emails and Slack and all of those things. There is no way of capturing all this metadata, centralizing them, giving the entire end-to-end context about data to people. So metadata itself is not done well. The other problem that we see is metadata is not used for its fullest potential, right? So mainly it's sort of used in applications called catalogs for discovery and some way understanding and governance, because GDPR and CCPA, all of these things came, right? And people had to react to them. And so metadata has been used for that, but there are many other innovations that are possible around metadata that is completely untapped today: data quality, data observability, and most importantly, people collaboration, right? Connecting people around data. And so I'll give you some details of how we are approaching this problem. Collaboration is the biggest missing piece, right, today in data. And that is the reason why getting data outcomes, reliable data outcomes efficiently is problematic, right? So now if you look at what has happened, because we have thrown a lot of tools and people at data, problem of discovering the data, you use a catalog, then you discover the data and it has quality related issues, you start throwing quality tools at them and start doing testing, attaching tests to your data and all of that. And then there's freshness and completeness and duplicate and missing data. And hence you now have observability tool that you throw at the problem. There's compliance, data management, data operation. many different tools are being thrown at the problem, and the fundamental issue here is these tools don't talk to each other, right? And each of these tools need to be integrated with various other things that you have in your data ecosystem. So there is that integration burden, and each of these tools are essentially underneath the hood. Under the hood, they are just sort of partial metadata systems. Catalog is the probably most comprehensive metadata system, but quality itself has what tables, what databases, what metrics, and then tests around that. That is also metadata, right? So uh, the metadata now is fragmented, duplicated in an inconsistent manner across all these tools, and they don't talk to each other, right? So catalog has PII tags and things like that, which is not available in quality tool. Quality tool has some kind of quality indicators that's not available in observability tool. And in order to stitch the big picture of data, a user has to jump from catalog to quality tool to observability tool to some other tool. In many cases, people don't even know some of these tools exist. And so there is general tool fatigue, right? So people have to stitch the big picture of data in their head, and it is not being done for them, right? So, and then of course, right, all these tools that you have to set up, manage is not only expensive for a data organization, but it is also operational burden, right, on the teams that are operationalizing and managing them. So that is one picture. Now, despite all these tools that are available in data, many different personas are sitting on their own tools of choices, right? A lot of them are not built for data at all. Developers are using Git, Docs, Jira, Slack, and things like that. Meanwhile, data scientists are using notebooks, ML tools, spreadsheets, and things like that. Governance folks are using something else. So every persona, based on what they are trying to do, there are tools not available for them, and they're taking some tools that were never built for data, and then they're trying to use it, right, to capture the context of data, the knowledge of data. And so again, right now, metadata is getting spread across all these different tools, and there is no way to bring them together, right? So it's a lost opportunity of building big picture around data, right? So some of these problems were problems that we solved at Uber. It was a big project. It's an end-to-end project, where we came up with solving these problems based on certain fundamental principles, right? Treating data as a code, having data ownership, right? Without ownership, there are no guarantees. Data quality is well understood and known. And then, having tooling to make data productivity easier and better, and collaboration of people better. And then finally, right, organizing for data, people organization for data, which is not thought through well. And it sort of looks like data mesh, but these are some things that we actually discovered and solved using first principles at Uber. And we made a huge dent in some of the issues that we were having with the data reliability and trust in data. Right. So there is a link to this blog. It is a lot bigger than this talk. Please do take a look at it if you're interested in what we did there. Now, one of the things that we did as part of this project is making sure that our metadata is centralized and made available through APIs, right? So we built at Uber what we call as U-metadata. So we built integrations in one place so that you can collect all the metadata, not just tables, databases, all the data assets you have around this. We connected all this metadata, centralized them, and then made them available through APIs, right? So few things happened because of this, right? Now there is a central repository for metadata stored as metadata graph, so that people can actually get complete picture of data in one place, right? Instead of jumping from tool to tool. The second thing that came out of this effort is simplification of our architecture. We had around 30 plus tools that we reduced to around 10 or so, even lesser, where many of these tools like quality, observability, some of this compliance, they actually were not standalone tools. They need not have their own metadata, and then data stored for storing the metadata, and then separate UI. Instead, they became just workflows, right? So take, for example, quality, right? It picks up test metadata from a table, runs the test, and generates the test results and writes it back into the same central repository. So because of this, many tools just became workflows, right? They are no longer standalone tools. You already have workflow systems like Airflow. You can, it periodically runs, computes all this, richer metadata, and then writes this enrichment back into the same single place. The second thing that I also want to call out is this wrong notion of catalog is a metadata system. What I believe is catalog is an application of metadata built for discovery. Now, if you flip this picture around, right, essentially a metadata platform has a centralized metadata store. Now you can start building all kinds of applications around it, catalog, quality, observability, and many other things. And many of these applications are just workflows, right? So you build certain set of recipes and they constantly run against metadata and they enrich metadata. The other thing that we also ended up doing is, in order to do people collaboration, we started building things like activity feeds. In OpenMetadata, we did not do this at Uber, alerting, conversation, and collaborative tasks. These are enabled because of this centralized, consistent source of truth metadata. Right? So there's a lot of innovation that can happen around OpenMetadata. There is a lot of data architecture simplification that can happen around metadata. So that is how we transformed at Uber. And this is what we are bringing outside through OpenMetadata as a project so that everybody can actually make use of this. So now, in order to build a metadata system, it has to have a comprehensive set of connectors to collect all metadata in an organization. So this is sort of dated. We have around close to 60 different connectors to various different tools that are available. And that kind of building connectors is something that we do on an ongoing basis, right? So that is one. The second thing is, based on the learning of building different metadata systems, and based on solving many data problems, if you look at fundamental problem with data is, a lot of times schemas are not well designed, right? I'm not even talking about metadata, just data, right? Schemas are not well designed, schemas are not documented, and because of which people misunderstand the data, right? A lot of times make wrong assumptions, because of that, they make mistakes. Maybe they are, confused and they don't even end up using the data. So schemas are very important for data. In the same way, metadata being the most important, aspect of data, schemas are also important for metadata. So what we are doing is starting with a schema-first approach, right? So design the schemas for metadata, the entities and the types, and build a strong core vocabulary for expressing the metadata. That way, now we can start driving it towards metadata standards, right? So I'll explain how it looks like in a subsequent slide. Now, we ended up taking JSON schema at Uber. We had built our own custom tool. But then, I looked at JSON schema, and I actually was very surprised by how rich it is and the kind of tool support it has. One thing that I want to say is, all developers must keep JSON schema in their arsenal of tool set, right? It's a very powerful schema language with excellent tool support. And what we have done right now is, because we start with JSON schemas and we design the metadata schemas, one beauty of this is we generate all the code for different modules from JSON schema using JSON tools. And the beauty of this is many things that are runtime errors and validation and documentation, all of those things are generated automatically and they become compile time errors. And every part of OpenMetadata, all the modules stay consistent with each other, right? Without actually putting any effort. I see certain messages in chat. Any questions, just interrupt me.
So far, no questions. We're just posting links and things like from your talk. Yeah.
Okay, awesome. Now let's take a look at why JSON schema is very powerful and how we are using it. Here is an example of an entity, user of OpenMetadata, who logs in and who interacts with the metadata stored in OpenMetadata. And that entity, we are showing a partial entity here. This entity is referenceable from any other JSON schema. So you can import and you can build against this by just importing using this ID, right? So the second thing is many of the constraints that are identified during modeling need not be, hand coded, right, in terms of validation and things like that. So here is an example of a field that we are defining. It's a type that we are defining within this namespace that has constraints like min length, max length. There are many other constraints that are available: min, value, max value, regex. There are different formats like date, time, URI. All of those are available, and they automatically define the constraints for this field, right? And this ends up becoming automatic validation on the server side for this data. Clients can validate it before sending the data. This also becomes documentation for our APIs. So it boils, it bubbles up all the way to APIs. I'll show you an example of it. So you are modeling it in one place, you are building all the constraints in one place, and it just gets used across your stack all the way to the APIs. The second thing, yeah, go ahead.
Sorry, one question from Eric Anderson. So what about evolving schemas? Eric says schemas need to be the point in time for the structure of the data at that date.
You are talking about the schema of the data. So we are talking about the schema of the metadata. The schema of the data itself, is point in time, and I'll show you what we are doing about it, how that schema evolves, right, and how that metadata evolves.
Nice, thanks.
Okay, so this is schema of the metadata, right? Entities that we are storing in OpenMetadata, not the schema of the data, right? Of a table or something like that, right? So, or a Kafka topic. The second thing that we also do differently here is many metadata systems, including the ones that I've built in the past, used to have key value pairs. And so you define a key, which is called property 1, property 2, and then the values can be any JSON blob. So there is no definitive shape to what an entity is, what keys mean, what values you can get. It provided an extensible model for entities. However, at the expense of being able to understand and human usable, machine usability. So here what we have is all the entities are defined and they have properties, and these properties use the types that we have defined, and these are reusable types across different entities, and each of these type have their own constraints and all of those things and documentation. That way now you're building core vocabulary for metadata. So these are sort of like words, and the entities themselves are paragraphs, right, that are built using these words that are well defined. So that's how we are defining core vocabulary for metadata towards slowly building it as an ontology, right, for metadata. And this structure is both human and machine consumable. There are a lot of tool support for this. And then finally, right, you can actually add many other constraints: what is required, what is optional. This is required, right? In many cases, many metadata schemas don't even express this. So you don't know what is required, what is optional, and you're just doing trial and error, and you're just writing if else conditions. All of these things are strongly typed and defined, right? So that is the power of JSON schema, and that is the power of schema-first approach. And then what are how are we modeling the metadata, right? So at the highest level, we have entities, right? So these are all subset of entities that we have, and these entities are built using our reusable types, which is our core vocabulary. Entities can be related with each other. You can have one-to-one, one-to-many, many-to-one relationship, right, between the entities. And through this relationship and entities that are stored in OpenMetadata, we are building a metadata graph, right? So one thing I want to call out is a lot of people are talking about metadata lake. I have seen, how data lakes turned out, right? People have stored all this metadata, all this data in data lakes without even knowing if it is useful or not. And, they're afraid to delete them because they perceive certain values locked in them, and they don't want to lose it, but they cannot articulate what the value is. And so, you keep hearing about how data lakes have turned into data swamp. We don't want metadata lake to turn into metadata swamp. And that's the reason why every piece of metadata that we are getting has its place in this metadata graph, right? Every time you are getting a piece of this data and connecting them in the metadata graph, it brings a lot more value than just the piece of data, piece of metadata that you have, discovered and, you have ingested. And so that is metadata graph. So just to give you an example of what this metadata graph will look like, there is a database service which contains an asset called database. Database contains table. Table is used by metrics. Metrics is part of a dashboard. Dashboard is built by a pipeline. Pipeline is consuming a topic. That is how, all these things are connected with each other. So this is sort of like, there's a lot of interest in lineage, which is through impact analysis and the causal relationship between the data sets, right? But this is sort of like superset of lineage, right? You're connecting not only how a data came to be through what processing, you're connecting all other kinds of stuff, right? So what contains what, who is the owner of that data, all of that, right? So it's a superset of lineage, and lineage is a part of this metadata graph, right? And finally, right, we have strongly typed schemas for metadata, but then for some custom needs that an organization might have, we have extensibility built. So the goal here is, unlike other metadata systems which left the exercise of modeling all the entities that are required in this metadata landscape, we try to define all the entities that are required, right? The second thing is all the properties, core properties of that entity, we try to define that. That is the basis of making metadata shareable. That is the basis of building open metadata standards. And at the same time, we have extensibility points, so that if you have something that is not generic and that is specific to your organization as part of a metadata that needs to go into an entity, you can extend them. So that's the approach we have taken. And then APIs, right? So APIs have transformed banking industry, financial industry. We believe metadata APIs will transform data industry. And that is the reason why there is a lot of effort this community has put in building strongly typed APIs. So we have gone away from what we had done in the past, where there's one endpoint which is called entities, and then you pass entity name is equal to table, and then you get any shape of form of response back, and then there is no specific methods to do certain things that is very specific to an entity. Instead, we have built specific endpoints for different entities. Different entities have different needs, and so they have specialized methods, right? I'll give you an example of this when I do the demo. Okay. And then finally, right, we want to make metadata shareable, reusable across different tools in the data ecosystem. And that can only be possible by defining metadata standards. And in order to build metadata standards, it has to be vendor neutral, right? It has to be community based, and there's no other better way to build it as open source project that has involvement of different kinds of stakeholders, right? People who are building data warehouses, people who are building ETL tools, people who are consumers of this metadata. All of those people should be able to freely participate, drive the standards that incorporates everybody's needs, right? And the only way to do that is through open source. And that is the reason why we are building this as open source. Finally, right, about the project itself. Today, we are one big blob of a project. We are, going towards, and that is because we are moving really fast, and we, want to continue to have that velocity. But in the near future, we are going to organize the project into 3 different parts. The first one is open metadata specification. That is JSON schemas for expressing the metadata and the APIs, right? This becomes the core open metadata specification. Anybody should be able to, import the specification, contribute to the specification, add to the specification, right? So the second part is using this specification, we have built an open metadata store. So it provides APIs, it stores the metadata in a database. It has connector and ingestion framework to collect the metadata from various different places and store them. Right? So that becomes an open metadata store. The goal here is many people are building metadata systems with a quality tool, with an observability tool. Any of those guys are, should be able to just pick this core part, embed it into their project so that they don't have to waste, time building integrations, building another metadata store, right? So, and then coming up with their own specification. Then With that, right, just metadata store is not sufficient. There needs to be an application that shows what is possible with open metadata. So we built an application for discovery, collaboration, and some kind of automation. I'll demo that to you. But the idea here is people should be able to use the core and build maybe competing application with what we have built as a community, or maybe something that is compatible with what we have built as open source community. All of those are possible. The goal here is I've seen hundreds of metadata systems being built in every organization, open source, vendor driven. In fact, some organizations have seen fifth, sixth iteration of metadata systems being built. It would be great if, we can eliminate 50% of those efforts so that instead of reinventing the wheel of metadata, we can start building innovation around that metadata. So don't reinvent the wheel, focus on building the cars, right? So that is progress. So that is a key goal, personal goal, and the community goal to make metadata solve problems so that people can build things around them. So quickly going over the architecture. So I will also highlight what went into these architectural choices and how it is different from some of the other choices that are available. As you get more experience as an engineer, you will start leaning away from more complexity to simplicity, right? So that's the journey that has happened for me also. So we have tried to keep open metadata as simple as possible. And then for people who want extensibility, there is pluggability so that they can handle the complexity that they need. For people who want to keep it simple, they can keep it simple. Now, our core dependencies are to a minimum. We have our source of truth metadata is stored in MySQL or Postgres. No unnecessary graph database dependencies, things like that. And Elasticsearch or OpenSearch is used for search and suggest. It doesn't, it can be recreated from the source of truth at any time, right? So it just is an enabler for search and suggest. And so those are core dependencies. The second thing that we have done is we have tried to build this open metadata using frameworks, open frameworks that have thriving community, that are making new releases and innovation in their projects. So we've used Jetty, Dropwizard, Java-based metadata store and an API server. And then we have used Python framework, which has a pluggable connector. And then through connector, you collect the metadata, transform them, and then write it using our REST APIs to the open metadata server, right? So this is different from few solutions have taken the architectural choice of just directly writing metadata into database, spilling over the implementation details into ingestion, and whenever they need to change the database, it's just impossible. So it's all API based. We have also used modern ever-changing JavaScript frameworks to build an UI, right? So I'll give you a demo of this. Now, one of the things that we have done is we built all of these things from ground up. We had built a similar system at Uber. A couple of reasons why we didn't open source them is internal technology choices of Uber, right? Which doesn't work for outside. Some proprietary technologies that became part of a metadata system, and that doesn't translate well to the outside world. And then finally, the third thing is architectural choices of large organizations are dependent on organization structure and organization boundaries. Not necessarily the right architecture. It's built for optimizing people collaboration and organization boundaries. And hence, architecture becomes overtly complicated and fragmented into pieces that they should not be for outside community. And that's the reason why we ended up building this from ground up, right? Solving metadata problem requires incorporating past mistakes and learnings from them and building it from ground up. So it's a clean implementation that open sourced in last August, right? So however, our community has been growing a lot, and there's a lot of adoption that is happening, which we are very grateful for. So that's the architecture. And then finally, one last call out is the power of JSON schema. So our Python classes are generated from JSON schema. Our TypeScript is generated from JSON schema. our Java, right, entity code is generated from JSON schema. And then the data that is stored in MySQL is compliant with this JSON schema. And finally, documentation is also generated from JSON schema. So highly encourage all of you guys to look into JSON schema for your other projects where it is applicable. Right. So with that, it's time to just showcase what we have done so far. Just metadata store is not sufficient. So we have built sort of like a catalog kind of experience, and I'll call out why it is different from catalog. So we have in openmetadata.org all these links that are available for you to go do your own further exploration. So here is our sandbox. It's a live system that we have built with how a typical enterprise looks like in terms of data. You can use your Google emails to log in. So this is our landing page, right? So here is where all your organizational assets are available in a single place. You can actually go and explore them and search them and all of that. So what does your organization have is available at your fingertips. And then this is your personal, whatever you're doing, right? You're recently viewing something, you're recently searching for something, you can continue that workflow if your workflow was broken. Now, data ownership is very key, important key goal of open metadata. So these are data sets that you have owned. So this looks like a list right now. And so some observability quality signals will start coming here. And then if you are a downstream user, if you are impacted by some data breakage of some table or something, you can follow them so that you can get alerted and you can understand what changes are going in. You can be in the loop, right? So that is that. Now, most catalogs focus on this box, right? Search for some thing, look at something, filter something, discover something. We actually want to build data collaboration experience, right? Catalog is a starting point. After discovery, what do you do? That is the missing pieces that we want to fill. There are huge gaps there. And that is the reason why we are starting with activity feed, right? This is one place to understand what is going on in your organization. How is data changing? Who is tagging what new data got published? All of those things are provided as activity feeds. This is different from Slack, right? Where in Slack you have a channel and then you're getting bombarded with all of this notifications. You are actually interested in just two tables, but there are 99 other tables that are sending all these notifications, and you're overwhelmed, right? Too much information sometimes is actually not good information, right? So here is the case where I actually want to just look at the activity for data related to what I own or what I follow, right? Things like that, right? So you can actually now use the context of who the follower is, who the owner is, and actually tie what activities are happening with the data, right? So filter them, right? The second thing that we are also doing is, from activity feed, you have to start the collaboration through conversations, right? And so a lot of this happens today where people send an email saying, hey, why did you tag this as tier 1, right? Or they will do Slack, they will do something else, which is not only context switching, it's lost, user interaction metadata. So here, I can actually just say, right? So these kind of conversations between people who own the data, people who consume the data, that is what we are focusing on. And I'll also show you, how some of these things come into play in other places as well. So that is activity feeds, conversation. People can actually have conversation. You can actually bring some fun into data, which is fairly boring by, having things like this where people interact without using words through emojis and stuff like that. And as always, right, there is discovery that you cannot avoid. So you can actually search for keywords, and once you search for your data types across tables, topics, dashboards, pipelines, and machine learning models, you can look all the matches right across different types of assets. You can also filter them, right? So you want only data in Redshift that doesn't have PII. You can, do those kind of filtering, right? So the other thing that we also did is, one of the key reasons why our data scientists would have hard time giving metrics is they search for sale, and there are like 4 or 5 different tables that look like they're all sales related. And data scientists use this, another data scientists use that, and they come up with different answers, right? So we came up with a concept of tiering, which is where, core to open metadata. We need to know what data is important, what data is not important. And we can then focus on improving important data, deleting unimportant data, right? So that's where we have come up with the concept of tiering. Tier 1 is the most important data used for sales, projections, financial reports, regulatory compliance. Tier 5 is people are creating in a self-service manner lots of data that never gets used, that lingers on. So we started categorizing that data based on the importance, source of truth data. This is used for business, important business purposes. This not only tells the data owner that the data is being used for important purposes and they got to be careful in how they evolve the data. This also helps in, maybe tagging, adding descriptions, tests, and stuff like that, starting with tier 1, because they create the most impact, and then completely ignoring tier 5 and deleting them. Right. So that's sort of what we ended up doing. And we started building this thing where if a data scientist is building a tier 1 dashboard, he should be using tier 1 data, right? Because tier 1 data will have better guarantees, ownership, and all of those things. And organizational energy is focused on making them better quality, right? So that's a concept of tiers. So let's say you discovered your data through all kinds of filtering and keyword searches and where it is matching and all of that. Then you need to understand the data. So here is where we are bringing different metadata that is collected from different places into a single place, right? So there is a summary view of what the usage is and how popular it is and things like that. There is schema, and some collaboration stuff here is I can actually ask, hey, can I the team that owns this, can you please add a description to this? And this automatically becomes task for the team, and it gets assigned right to them. So I can also assign other people. So no need to jump to, let's say, separate Jira, send an email. The tasks are created right here without switching the context. These tasks are tracked for the user, right, that owns this tasks, right? So that he can go provide whatever that is requested. You can also do collaborative development of descriptions and stuff like that. You can suggest descriptions, right? Sometimes data owners don't know understand the data. Somebody else can actually suggest a description, and it's sort of like a pull request. People can actually accept that description suggested. Those kind of collaborations are available, and all of this is tracked for you right here. Right here are all the tasks that are there. Right, you can actually just look at, hey, how many tasks are pending here against this data set, and then you can start solving them. There is sampling of the data so that people don't have to write queries to just look at the sample. What queries are running in your organization so that people can cut and paste and make use of this, sort of learn from something that's going on. We have data profiling. So we actually look at the data distribution within your data. You can actually set it for certain partitions, sampling of data for the entire data set, depending on how big the data is. Now, let's say here credit card, right? 50% duplication of credit card is a serious problem. Now, this data is not high quality, and you should be able to write sort of like great expectation tests. You should be able to click and then add whatever test that you want, right? And these tests are automatically run. Success failures are provided to you, and then you get alerted when these semantic checks that you're adding at a column level or at a table level fails. You get alerts, right? So there are two kinds of tests that we have enabled, sort of similar to great expectation. You can add table tests, right, where you have a whole bunch of things that you can test. And then you have column level tests, right? And then you can also write your own custom queries to, write tests, right? Lineage, this release, we are super excited. We introduced, not only we have table level lineage, now we have column level lineage. So you can actually look at column level lineage, and not only we instrument this through query analysis, DBT, and Airflow, you can also just hand edit it, right? So this is something that we have uniquely, where you can actually, if there is something wrong, you can edit it and clean it up, right? And capture your organizational tribal knowledge. You can add custom properties. This is the extensibility aspect of an entity metadata. And then you can tier them, you can manage ownership. Now, one thing that we are super excited, and Eric, you were asking about this, the schema of this table, as it evolves, we keep track of all of that changes, not only schema changes, everything that has happened in terms of metadata through versions, right? So somewhere here, I changed the owner as data platform. Somewhere here, somebody added the tags. If both the changes that are happening on open metadata, where people are changing the description tags and stuff like that, changes the version. It also, the version changes when on the database, if somebody drops a column, adds a new column, we change the version here. And then when somebody drops a column, which is backward incompatible change, we also change the major version number to show the backward incompatibility and create alerts. So everything that has happened for a data in your organization is never lost. That's a rich metadata that is captured here. And then, of course, right, you can add tags at the column level. You can add tags at the table level. So let's say this is personal data. I can just add those kind of tags, both at the table and tag level for governance purposes. Right now, this same rich set of functionality is available for topics. Right, so Kafka topic has a schema. It has activity field, versioning, following. You can tag them and things like that. You can actually see the sample data if you set it up that way. You can manage them. Also, a bunch of information that is relevant for consuming this Kafka topic is available right here for people. So that is a Kafka topic. We also have similar things for dashboards. We support a bunch of dashboarding tools, and you can actually go look at the dashboard, again, tag them, look at activity feeds. You can have tasks associated with it, versioning, following. All of those things are available, right, for dashboards. Same things are available for pipelines. You can actually look at the pipeline information, how pipelines are running. If there are activity feeds, you can actually look at the lineage of a pipeline at the pipeline level, not at the data set level. That rich information is available for you. And then we newly introduced ML models. Would love to get some feedback from you. So here is an ML model. What features are there? How is that feature generated from what data, right? And some details like what are the hyperparameters, and then again tagging, following, versioning. All of those things are available here, right? So and then. So that is, data assets, right? Discovering and understanding data assets. Governance is a key piece, right, around metadata. So we have tags for classification and categorization, and all our tags are hierarchical. So here is personal data having personal and special category as tags under the personal data category. Tier itself is a tag for us. So under tier, we have all this tags that are available under this category. Similarly, we have glossaries. Now, tags are for classification, categorization, small snippet of information. Glossaries are a lot richer. Unfortunately, in the data world, business glossary is an established word. What we have is essentially a thesaurus from knowledge organization world, where you can actually not only capture terms, you can actually capture abstract concepts through hierarchical structure like this, where one a term in one hierarchy should be able to have relationship with other hierarchy, and that's how you do conceptual connections and discovery through conceptual understanding. So we have business glossaries and review process associated with it for data governance and things like that. Ownership is very important for us. So we have concept of teams and users. So the team ownership is shown right here. Right, so data platform, which I am part of, has a bunch of assets. You can define roles within the teams, and then you can manage users within the team. So here is data platform. These are the assets they own. You can also look at all the users that are there, in your organization, right? So that's team organization. We also have roles.
Suresh, if I could interrupt, we have a lot of great questions popping up in the chat. And
If you
thanks.
don't stop me, I will keep going at 100
Yeah,
miles per hour.
maybe
So
we better
thank you.
ask those questions now. So I'll read
Yes.
them, and if we get through them, then folks can unmute and we can have conversations. So the first one, maybe Marissa answered the first ones, but Preeti asks, is there lineage available at dataset to pipeline or pipeline to dataset level?
So data set to pipeline to data set. Then data set to DBT model to data set. There are different levels of information here, right? When you do column level lineage, the pipeline in between is not the right way to show it. So we have rich lineage, and there are different views for it. Data set to pipeline to dashboard, right, all the way to the end, the data asset that you create. And all the required details are captured, right? DBT modeling, pipelines, direct relationship with between columns with a SQL query that is that was used for generating this column level lineage. So even the queries are part of lineage.
Nice, awesome. Eric asks, are there any plans to show the results of automated data quality testing? In particular, he's referring to DBT results.
So DBT tests we need to still integrate as metadata. And what we are going to build is some kind of dashboards here that gives you different kinds of reports, right? How you're doing in terms of description coverage, tag coverage, quality, and all of those things. And as part of that, we will surface not only right now at an individual table level, we are providing all this information. It will get aggregated at a team level and an org level. So there will be some dashboards that we will start making available. Stay tuned for that.
Great. I have a question. So how frequently are these entities indexed?
They are indexed right when they change. So what we have is change events, and we actually support webhooks. If you want to build a server, we can send all the metadata change events to you over webhook, or we can publish it to Kafka. We have an internal thread that consumes these event changes. So we have rich chain event notification, and that is used to update the Elasticsearch, in real time.
Exciting. Lots of interest in this topic. We just have a few minutes left. If somebody wants to unmute themselves and continue with the conversation, also I'll post the Slack channel for OpenMetadata, and we can continue the conversation there.
Yeah, so one thing that I want to show is we have support one-click integration, so you can add new service, and there are all these services that are available. You provide your credentials, automatically we kick off ingesting metadata, and there are different services that are available that you can explore. And we also have APIs right here for you. You can take a look at all our comprehensive APIs. One quick thing, just showcasing the power of OpenMetadata JSON schema. Here is the example that I was showing, right? The name has certain constraints that we defined in JSON schema, comes all the way up to API and automatically gets validated, right? So the contracts are defined and made clear everywhere. At this point in time, I'll stop and answer any questions.
Yeah, Brad has a question here. He asked, does it maintain version history? Brad, maybe.
Oh, yeah. We just now showed the version history for a table, right? So that version history is maintained for every entity. So here is an example. Play around with this, right? We keep changing minor version and major versions as things related to your entities change.
Awesome. Let's see. Thanks, Marissa, for posting the Slack link. We can continue the conversation there. Maybe we just have time for one, maybe two more questions. Marissa, you were answering Ken's question earlier. Will OpenMetadata include data pipeline observability and or open lineage project?
No, I think open lineage is a way to capture lineage information, right? But we are capturing a lot more metadata than lineage. We need to anyway build connectors to all these sources to collect the metadata. So lineage is just a small, but important piece of metadata that we already capture without using open lineage. The second thing is open lineage is collecting the lineage information, but it needs to be stored somewhere, right? So, and that's where it uses Marquez. That's where open metadata is sort of equivalent to Marcus, right, in terms of metadata repository. And then finally, right, open lineage is a small snippet of just instrumentation that is being collected for lineage. In fact, if you look at the standard defined in open lineage, there is no lineage definition at all. It's all about runs jobs and when they ran and who ran it, and pipeline information, which we are anyway capturing. And so it's just a small subset of all the other metadata we are capturing.
Nice, exciting. In the interest of keeping everybody's time, I have tons more questions, but I'll join you in the Slack. I want to make sure I respect everybody's
I can
time.
answer for a couple of more minutes if that is okay, but yeah.
Okay, yeah, I'll go ahead and thank you, and we'll stay on for more questions, but thank you, Suresh, to our speaker. This was fantastic. Thank you to AI Camp for making this possible in this distributed environment. And I must say, open metadata is going to be helpful for working just with distributed teams a lot. So thank you so much. Anybody who needs to drop, feel free. We won't be offended, but we'll stay on for 5-6 more minutes to answer questions. And feel free to unmute and have a conversation here.
Yeah, and we are building this at a tremendous clip. So if you have ideas, if you want certain features, please, do come to our Slack community. So here is, we do monthly releases, and this is what we did in the latest release, right? Data collaboration, task announcements, emojis, column level lineage, custom properties, advanced search. Similarly, in the previous release, we built a whole bunch of features. So we are moving at a really rapid pace. We have a thriving community. Would love to invite you guys to our community and get your ideas on what problems we can solve.
There seems like a lot of excitement around this. Brad, did you have a question?
I did. I'll just jump in and say, Suresh, thank you so much for an amazing session. This was really insightful. I'm the founder of Culture Mindful and our chief product lead. So full transparency, I'm just getting into the space. My CTO is not here with me today. I'm just trying to factor in, just for context, we're building a digital product to assist organizations in helping them cultivate culture mindful workplaces to boost workplace performance and mental well-being, workforce performance and mental well-being. So there's an element of the product that we're building where we're working with customer data, right? So we're taking in sensitive data from our customer, implementing it in our product that will go back and get used and constantly get updated over time. So employee information is an example. So when we onboard a customer, they'll start off with an X number of employees, and then over time it'll kind of go up, go down, depending as their workforce kind of shifts. How would you advise me to further understand how your product, how your platform works, and how we can factor it into our product build so that we can develop and execute on our mission in a more meaningful and effective way?
I think this definitely requires a deep dive conversation in Slack.
Yeah.
To understand more details of what you're trying to achieve and stuff like that. In here, what we are trying to do is get some excitement and make connections around data of people and help them collaborate. And then what I actually did not talk about is today metadata is stuck in this world, right, where it's all discovery. We want to actually move it towards collaboration. And then once you have all of these things, a lot of automations can be built. One of the automations that we will start building is giving feedback to people that you're doing great. Here is some things that are required. Here you can add description, build some fun into data where instead of top-down mandates, constantly, send them, hey, you're doing great here. Here it can be improved. That kind of stuff. So, that is a slow transformation of data culture, right? You never transform it through top-down mandates. It's got to be slow, on the slow burner, and then constantly giving feedback.
Right. Absolutely. Well, this is very interesting. I'd love to connect and discuss this further. Marissa, thank you so much for the invite to this event and such a quick turnaround. I believe we were connecting on LinkedIn and going back and forth. So thank you for that.
Yep, correct. So glad to see you, Brad.
Yep.
Awesome. Is there anybody else who has one more question?
I have a statement for Brad. So we use Apache Ranger integrated with Trino, integrated with OpenMetadata to address that sensitive data. We're planning on integrating Ranger into OpenMetadata too, which is an access control authorization system to allow people to see stuff. So your problem is noted and everybody kind of knows about it. So we've talked about it quite a bit. Just we haven't had a chance to prioritize it as work yet.
Gotcha. Awesome. Thank you so much, Eric. Appreciate that.
Eric, will that integration be open sourced by any chance?
Oh, hell, I don't want to maintain it myself. Trust me.
Yeah,
You have to.
Eric is
given them-
author of many of those things. So
Fantastic.
Yeah. I'm finishing the Trino open source now, and then I don't know if myself or somebody else on my team will do in the Ranger integration with OpenMetadata. It's needed, Brad. We know that.
Awesome. Awesome.
Fabulous.
Thank you.
Well, I will leave it there because I know folks have to, get back to their day jobs. So this is a fantastic discussion. Thank you, Suresh, for joining us. Thanks, everybody. Thanks for the conversation.
yeah,
Thank you so much.
thank you everyone for your time. And yeah, again, thanks for arranging this.
My pleasure.
Thank you. Thank you.
Thank you, everyone. See you later. Bye.